All right, let's jump right in. In this explainer, we're going to tackle one of the most fundamental questions you'll face after you've built the Cisco ACI fabric. How in the world do you connect it to everything else?
So, you've done it. You've built this incredibly powerful, policy-driven data center. You can think of it as its own little self-contained universe for all your applications, with its own rules, its own security, the whole shebang. But, it can't just be an island. Your users have to get to those apps need to talk to the internet or other services, and you've probably got legacy gear that needs to communicate with this shiny new fabric. So the big question becomes, how do you build the bridges from this ACI world to everything else? Your campus, your WAN, even other data centers. Well, that's exactly what we're here to figure out.
Okay, here's our game plan. We're going to start by talking about why connecting ACI is a unique challenge. Then, we'll get into the most important concept, how ACI sees the world in terms of inside versus outside. After that, we'll dive deep into the two main ways to connect, the Layer 2, L2 out, and the Layer 3, L3 out. And finally, we'll see where all this stuff actually gets configured in the APIC controller.
Right, so the main thing to wrap your head around is that ACI just doesn't think like a traditional network. It's all about policy. You define who is allowed to talk to what. You can't just plug in a trunk cable, configure a few VLANs, and call it a day. It doesn't work like that. To get out of the fabric, you have to use specific, policy-based constructs that bridge the gap between ACI's world and the traditional network world.
Okay, before we go any farther, this next concept is absolutely crucial. You have to get this. In ACI's eyes, if a device, a server, a VM, whatever, is part of what's called an endpoint group, or EPG, it's considered inside. Think of an EPG as a container for things that have the same policy needs. Simple enough, right? Well, that means everything else, literally every other network or subnet that's not in one of your EPGs, is considered outside. The connections we're about to build, these L2 outs and L3 outs, are the controlled gateways between these two worlds.
So how do we actually build those gateways? Well, ACI gives us two main options, and they're built for very different jobs. The one you pick really depends on what kind of conversation you need to have with that external network. It all boils down to a classic networking dilemma. Are you trying to stretch one big network, or are you trying to route between different networks? And this slide really nails the difference. An L2 out. Think of it as a super smart, policy-controlled trunk port. You're basically taking a broadcast domain that lives inside ACI, which it calls a bridge domain, and you're just extending it, stretching it out to a regular non-ACI switch. On the other hand, an L3 out is all about routing. It's how your ACI fabric becomes a good citizen in your larger network, learning routes to the outside world and telling the outside world how to get to the apps living inside the fabric.
Okay, so let's peel back the layers on that first option and really see what it's all about. The Layer 2 out, or L2 out.
So, what is an L2 out, really? It's the official ACI object you build to connect an internal bridge domain to some external Layer 2 device. And remember, for our purposes, a bridge domain is basically just a broadcast domain, what you'd normally call a VLAN. The L2 out is the policy that says, hey, I want to allow this specific broadcast domain to go out of these specific ports using this specific VLAN tag. It's the most straightforward way to get Layer 2 adjacency with something outside of ACI. So when would you actually use this thing? Well, think about a migration. Maybe you're slowly moving servers into ACI, but they still need to talk to old servers on the legacy network. Perfect use case. Or what about a big firewall cluster or a load balancer that needs to be in the same broadcast domain as the servers it's serving inside ACI? An L2 out is your answer. It uses standard VLAN tagging, so it's super compatible, and it lets you make that connection happen while still keeping all the policy and security benefits of ACI. All right. Let's switch gears, because most of the time, you're not just stretching a VLAN. You need to connect to your campus core, your WAN edge, or the internet. And for that, you need to route. This brings us to the much more common and, frankly, more powerful method, the Layer 3 out, or L3 out. Right off the bat, an L3 out is a completely different beast. Its whole purpose is to create a routing relationship, an adjacency, with an external router or a firewall. With an L3 out, ACI isn't extending a broadcast domain. Instead, it's using this connection to learn about all the networks that exist outside the fabric, and just as important, it's advertising all the application subnets that live inside the fabric. It's literally the gateway between your ACI tenant and the rest of the routed world. And this is what makes the L3 out so powerful for network folks. You're not learning some new, weird proprietary protocol. We're talking about the bread and butter routing protocols you already know and love, OSPF, BGP, even EIGRP. You can form an OSPF adjacency with your core, peer with your edge routers using BGP, or tie into an older Cisco network with EIGRP. And hey, for simple things, you can always just use a static route. This is the toolbox that gives your applications full connectivity to anywhere they need to go. Okay, that's enough theory. We've talked about L2 outs and L3 outs. Now let's see where the rubber meets the road. Let's pop the hood and look at where you actually build all of this inside the Cisco APIC, the brain of the whole operation.
So when you log into your APIC and you click into a tenant, you're going to see a folder called Networking. Now, don't let that simple name fool you. Pretty much everything we've talked about, all the fundamental pieces that make communication happen, both inside the fabric and out, it all lives inside this one folder.
And if you pop that folder open, it's all there, laid out logically. You've got your bridge domains for your layer 2 networks, you've got your VRFs, which are your separate routing tables, then you have the dedicated folders where you actually build your L2 outs and L3 outs, and that last one, the external EPG, is super important. It's basically an object that represents the outside world, so you can write policies or contracts to allow your internal apps to talk to it.
And here's something that's just awesome about the APIC. It's not just a bunch of configuration menus, it gives you this logical topology view, a visual map of your design. You're not just guessing how things are connected, you can actually see it. You can see at a glance which bridge domains are tied to which VRFs, and how your L2 outs and L3 outs are providing the path to the outside world. This makes understanding your network and troubleshooting so much easier.
Now, let's zoom in on this specific example because it shows something really cool about how flexible this is. See that one box, the presales_VRF? That's our routing table. Now look what's plugged into it. On one side, we have an L3 out that's running OSPF, talking to some other router. But at the same exact time, that same VRF is also the gateway for an internal bridge domain, which is also being extended out of the fabric using an L2 out. That's a huge concept. One single routing domain can support both routed and bridged connections to the outside world, all at the same time.
So, at the end of the day, it all boils down to this one simple, crucial question you have to ask yourself. As you stand at the edge of your fabric, ready to connect it, what does my application actually need? Does it need a seamless Layer 2 extension to feel like it's on the same old network? Or does it need standard Layer 3 routing to talk to a bunch of different networks? Your answer to that question will tell you point blank whether to build an L2 out or an L3 out.